All right, welcome to sig-auth for May 27th. Let me go ahead and present the agenda. All right, let's get started. Poll of note, I shared this a couple months ago, the sort of proposal around pod security standards, and the PR has merged. It's now part of the Kubernetes documentation, sort of laying out these three recommended policy levels. I noticed yesterday that there's a couple of restrictions that are missing, and so I'll go ahead and add those soon. But if you have more thoughts on this, take a look. And yeah, right now it's just a documentation page, and we'll be kind of adding to it and evolving it as needed. Any questions about that before I move on?
Do we have a recommendation for people who are going to be sort of implementing enforcers for these to subscribe to or keep up with, like how these recommendations evolve over time, especially around new capabilities?
Yeah, that's a good question. No is the answer, but that's a good idea. Do you have any recommendations for how we might set that up?
I vaguely remember discussing sort of like a test suite type approach to say, like, if you have a restricted policy in place, these things should be able to be created and these things should not be able to be created, similarly for each of the levels. Having a way to run that set of tests against an arbitrary cluster with an arbitrary policy enforcement mechanism seems really useful, and that would let someone not just subscribe to a doc update, but actually like run master versions of that and notice when, like, hey, the restricted thing, this new thing came in and we decided, like, here's where it fits in this policy. Like, I need to.
Yeah, that's a good idea.
One other thing that just I didn't see noted here is that pod security policy is beta with no current plans for promotion, as far as I know. So that seems worthy of noting here when it's being linked to and referenced.
Yeah, I can add that. Those policies link through to the pod security policy documentation, which mentions that it's in beta, but not that we don't plan to move forward with it.
Yeah, I think that's worth bubbling and making prominent.
Yeah.
Okay, thanks. I'll follow up with those. Okay, next up, API server per request MTLS. Who added this to the agenda?
So I added it. I'm Colton, and I'm from Apple. I've got Bob on the call with me, and he's on our traffic team. Knows a lot about networks and authentication. He works on a lot of the auth for our organization. It was a member of his team that discovered this, that basically and I think it was like intended to be this way. I think that just the ramifications are at scale, we end up having a lot of useless work being done in the server because we can effectively use connections as that caching layer, that as long as you have the connection open, you can trust the requests going over that connection because you've done the cert verification up front. But that's not how it works today. The way it works today is you establish the connection without doing any MTLS, and then all the requests that are streamed through that single connection are doing the expensive CPU on the, well, to us it was super expensive because we have really deep cert chains. But this basically becomes a bottleneck for the API server at like a really large scale for like a lot of pods or a dimension of a lot of kubelets, because once you hit a certain amount of requests per second, you can end up with like a rolling death effect, where all of the API servers can't handle the requests in time. And instead, if you just eat the CPU of the initial connection handshake and doing the MTLS there, we saw that, you can see in the graph below that, I mean, it got rid of the CPU problem on the API server. So right now we have to carry the internal patch. What we'd love is to be able to just have an option to turn on this alternative way of doing the verification and the caching with the connection instead of doing it on a per request basis. But there's been a lot of debate about maybe just having a different Golang option. The problem is, I think the Golang option for verifying it if the cert's presented means that you still can bypass auth giving like an unverified cert. So I don't know how that passes the edge case of like, let's say I give an invalid cert claiming who I am, then if it's not done at that connection time, or if I don't give I guess, yeah, I mean, I haven't thought through that option too much, but I mean, the upstream Golang change is just going to take a really long time and might not be accepted by the community. I mean, we can try to do it that way. But I think the easiest one for us, at least, and that made a lot of sense that like we could directly contribute to, is the separate implementation that like, I mean, this is like, we're a part of the division that's doing Apple's like centralized infrastructure. And so this would be like a pretty well-trodden code path that's like vetted by our security team and is pretty important, to like Apple's security. So I just mean, it's not like it's a small team that's just like using this one implementation of auth. Like we would be contributing and maintaining it, is what I just wanted to say, I guess.
So,
and like we could implement number 5, but it doesn't solve, like that is just the worst implementation from our perspective. So like no one would use it really if we like implemented like doing caching in memory of the cert chain, the cert verification.
What do you mean no one would use it?
Like we wouldn't use that. We would just carry the internal patch does a much better job of just addressing the problem. Like it doesn't require any additional memory usage or a cache or anything. Like it just it like uses, it's effectively like not going to use any more memory than
yeah. So the concern with switching to the standard library verify on connection was that it breaks clients that present client certs that are not intended for authentication to the API server. So that, like going back, whatever, 4 or 5 years, like those were the clients that prevented us from using the standard library method in the first place. Otherwise, we would have done that.
Right, because they basically wanted to be able to do like, okay, I'm submitting an invalid cert, but really I'm trying to do token off, for example.
Right, or
just,
it
like,
was
chooses
clients
the right one.
that present a client cert to all outgoing connections, regardless of the server. Like this is my client cert that I use for like corporate proxy authentication, or like this asserts my identity, and I need it for like some non-significant percentage of the network requests I make, and so I spray it out like to any connection I make indiscriminately. So the Go clients don't do that, but some clients do, some browsers do, and yeah. So I think we try to avoid adding sort of alternate configuration paths that can't reasonably be enabled by default or broadly. And so this is the sort of thing, like, do you have clients making connections like this? It's hard to know until you turn this on and then discover, oh yeah, it turns out I did, and I just broke like X% of my clients. So my ideal scenario would be if the standard library supported doing this. Like, by all means, verify the TLS connection at connection time.
Right, but we'd break the existing clients. I mean, so that's why, like, I mean, when I originally proposed the idea, I was like, I'm pretty sure, it breaks assumptions that have been made around the server behavior. So we can't do it that way, I don't think. I mean, maybe, I mean, I know that there's like, between certain major versions, we can make breaking changes, but this is breaking like so many clients and, third-party integrations with Kubernetes that, like, I think it would be a unfortunate thing to try to just upstream directly to the existing auth implementation, which is why I didn't propose that. I didn't consider the like hesitation of having it behind a flag, because if it has a big impact of breaking things that's like discouraged against. I was trying to think of examples where we have that today with certain feature flags. I know there are some, but for auth,
most of the feature flags that we put in place are expected to be temporary, like, and they gate behavior during development and testing and maturation of a feature, but then they're expected to graduate and be on by default and no longer have, sort of doubling our test matrix long term.
Do you think that the community would be against switching clients eventually over to like a per connection, like doing the TLS up front and providing either choosing to do cert authentication, or, I mean, I think you were talking about the fan out. I think, Bob, you said that there's a way to address the fan out issue for like when you're like blindly sending certs to like multiple, or I think also Jordan, you brought up something about browsers forwarding like certs blindly or something. Is that right?
Mm-hmm. Yeah.
Yeah. So I mean, we wouldn't be able to change that behavior or address that use case. So
yeah. So I think what Mo said.
I mean, unless there's a way to separate the initial TLS authentication code path from the I have connected and now I am sending some other certificate because that's what I do. But
I'm not quite sure I follow. Like, if we re-implemented enough of the standard library, we could do this in tree, but I would really like to avoid that. I think what Mo said kind of matches my thinking. Like, I would like to see this option supported by the standard library. So I would encourage requesting that. And like, if we get that from the standard library, that's great. Until we do, it seems like the caching of saying, like, we saw this leaf certificate that was verified in a handshake, so we know you have a private key, and we already verified the chain for that and memoized that. That seems like it would not be unreasonable, and that would avoid giving us a configuration knob that we don't really want long term.
Yeah, I don't want to forego the expiry time validation in general. So we could either do like partial evaluation or just do like caching per request. If we had like a cache for 1 minute, I think that seems reasonable.
You can even pin the expiration to the date on the cert. So.
Yeah, you could, if you were caching it, you could still validate the expiry time. Validating the expiry time is cheap. It's the public key math that's expensive.
Right.
Yeah, I think I wouldn't even care if we are doing revalidation every minute or so using some expiring cache.
So yeah, that would be my feedback if you wanted to contribute this and not carry a custom patch. So that seems like the best balance between keeping compatibility, but also hopefully unblocking expensive verifications, deep chains, or big keys.
Okay. Yeah, that makes sense. There's like a middle ground for it. Okay. Okay, cool. Thank you guys so much. I really appreciate it.
Yeah, it's always fun to see someone running into things and like paging in. Like I remember running into this. Why did we do this?
Yeah. Oh yeah, totally. I mean, it's like probably been around since the beginning of it. So yeah, super interesting. All right, thank you.
Yeah.
Thanks for bringing that up. All right, next up we have external TLS certificate authenticator. Cap. Who wants to take this one?
I could take it. So hi, my name is Christian from Elasticys, and together with me on the call should be also Jakub. Yep, he's here. And we have been working, we have been contracted, just to give a bit of a history to this project, we have been contracted to implement PKCS 11 standard in kube control. So the client was asking us to comply to certain security requirements of theirs, which was to avoid as much as possible to have any kind of soft tokens in their system. And in their opinion, things like, for example, TLS resume tickets or private keys, that is kind of how nowadays most of the people do authentication against the Kubernetes API, are soft tokens. They would rather prefer this thing to be delegated to a hardware security module via a standard such as PKCS 11. Now, we prepared a small presentation to follow up on this enhancement. We also have a small demo. I'm not really sure how to make the best use of the time of this community. We also got 2 new feedbacks shortly before this this meeting. So I'm not sure what would you prefer. Would you like me to go through the material we have so far and bring everybody on the same page so as to gather more feedback, or should we just dive directly in?
Can you go through the presentation in about 5 minutes?
Yep, I could do that. Would you like me to share the screen?
Yes. Right, you should be able to share now.
Host disabled participant screen sharing.
Right, you should be able to share now.
Does everybody see my screen now?
No.
That's pretty disappointing. I keep clicking on the share button, nothing happens.
Do you want to share? Can you link to the presentation from the agenda, and I can present it?
I could do that
Or is it
too.
more of a demo? Or?
I have. I think I would rather do the demo in that case, but we can also go through the presentation if for some reason sharing doesn't work right now. I added the link in the agenda. Can you access it?
I requested access.
Just a second. I found a window that Zoom spawned somewhere, and
Okay.
do you now see my window?
Yeah.
My screen.
Great.
Oh, okay. Apparently there was a window that I haven't noticed. Let me then go to the demo because I find it pretty pretty self-explanatory. So the key recordings are pre-recorded, but the commands itself that are executed and the output is real. So like I said, let me just run this external plugin here. So I'm right now having a Minikube cluster running on my laptop, pretty standard things. And the thing is that by default, the way clients are using Kubernetes, unless they're very knowledgeable, is that they have some kind of private certificate somewhere, most likely on their system. And I know that this is a bit of a controversial topic, whether you should use OpenID or whether you should avoid certificates at all, or whether you should just go ahead and use OpenID. But at least all of us kind of seem to agree that at least in break glass scenarios, you do need private keys. And so, like I said, we're contracted to avoid these kind of attacks where, for example, somebody would be able to gain access to your private key by just stealing your laptop and then doing a cold boot attack or something like that. And to this end, we have used the hardware security module like the YubiKey, which is pretty popular. So you can either generate the, an RSA key on the YubiKey, or you can just import a key onto it. So I'm going to do the latter right now. And then basically I can just wipe my client key and my client certificate. Now, of course, I have lost access to my Minikube cluster. So let me now reconfigure it. And this line is, let's say, the core of the contribution. So we basically added a new authentication provider, which we call external signer, which gets as parameter a Unix socket with which it talks to another process called external signer. So this is running right now in the lowermost terminal. And then all the other parameters are basically just sent directly to the external signer. We chose to do it so that the user can potentially configure the external signer from their kube config without having to spawn several executables for each kind of configuration. And so the idea is now, for example, yeah, this is the final result of how now the Minikube user is being configured. And if I now do kube control pods, then here we still left a little bit of verbose messages. But the idea is that the external signer actually has the possibility of giving a user prompt into the kube control to basically announce the user, hey, I'm waiting for you to touch the YubiKey, or I'm waiting for you to type the password on some kind of external keyboard. So then that action would be very much depending on the external plugin. And then type my super secure pin 1, 2, 3, 4, 5, 6. And it's afterwards that the TLS handshake can complete, and I can actually look at what's running in the Minikube cluster. So how many minutes do I still have? Let me maybe skip ahead to this particular slide. But the thing is that we presented the first version of this contribution at sig-auth on March the 4th. At that time, we had a rather monolithic implementation where everything was in kube control. And this, of course, was very problematic because it basically forced kube control to be compiled with sig-auth. This is required in order to use the PKCS 11 standard, since it's basically a protocol in which a dynamic library SO is being called via C-like interface. So then we worked on that a little bit. We worked on a second version, which is the one that is right now contained in the enhancements proposal. There we have two components. So the kube control is now having basically no extra dependencies, and it's just talking to a Unix socket, to an external binary, which is then containing all the, compiled with sig-auth and doing all the heavy lifting. This was then also problematic because we were inspired heavily by the exec credentials plugin. And apparently nowadays that is no longer favored because theoretically it would be possible for you to download a malicious kube control file from the internet. And so the community expressed the wish to reduce this kind of risk in the future. So then the demo that I've just presented to you and the comments that we have left at the end of the CAP is basically the third version of the implementation, in which again we have two components, so the kube control and the external signer. They communicate via gRPC over Unix socket, so this can take advantage of the regular protection mechanisms offered in usual operating systems. And our understanding is that the latest version of Go also supports Unix-like sockets on Windows. And it also allows you to send back to kube control prompts, so that it's no longer in kube config that the pin is stored, or it's no longer kube control that intermediates the pin. There are also some hardware security modules that just they have their own keyboard, for example, and they don't use the keyboard of the host. So in any way, we feel that this is a pretty flexible solution that allows all kind of future use cases for avoiding private keys in kube control. And this latest suggestion also has the advantage to that it says the cluster name via gRPC. So you could also potentially not have any configuration in kubeconfig and do the multiplexing and the matching between keys and the clusters in the external signer if anybody wishes to do so. So this is pretty much the architecture. When TLS setup is being done, first the certificate request is being sent to the external signer process, and then later during the TLS setup, a sign request is being sent again, which is handled by the external signer. And I think what the critical point right now to discuss, at least for us it feels, is if the API, so we're suggesting an API to communicate between kube control and external signer. And we want to know if this is adequate or if this still needs some work. We already have received just before 2 hours before this call some feedback, so I guess we will need to start by addressing that one. And afterwards, we would like to discuss, so we have received strong requirements to make this contribution upstreamable. So we have missed, of course, the 1.19 deadline, but we're wondering, like, do you see any major impediments, or what should we else need to work on in order to have an alpha version aimed at Kubernetes 1.20?
So I left a comment on the issue a while ago, but I didn't get a response. I think the big things for me are, I would really like to have the clear requirements before we do this. And I don't have that clarity yet. For example, like if you have very specific PCI, DSS, or whatever NIST recommendations that we could look at to like rationalize these design choices against, that would be helpful when reviewing the design. So trying to understand, I'd like to understand what why your client is requesting this specific solution. And then the other thing is I'm also trying to figure out why this looks so different than FIDO, which seems like the prevailing standard for user hardware-backed login.
So I can try to give, so first of all, really sorry that I missed your comments. It's just in the meantime, we have been working on so many other things that I missed to.
Yeah, no worries.
We kind of, I feel that some of these we addressed them, but without really saying that we, how we explicitly address them. But I can maybe take them, scratch the surface right now. So with respect to, you were asking this, the question regarding the second factor is the by touch ID or YubiKey touch policy. So right now, since there is a strong separation between kube control and external signer, this is really something that is the responsibility of the external signer. In the world of YubiKeys, for example, or PKCS11, you can actually say that every single sign operation needs to be authenticated. So which means that every single sign operation needs a PIN or it needs a touch or something like that. Or otherwise, you can also say that, well, you just authenticate once and then you can for a certain amount of time do sign operations as you wish. I feel that currently with the current architecture where you have a user prompt being sent back to kube control, we basically externalize this choice to the external signer so that whatever regulations or whatever security policies an organization has, they can be adapted to whatever is necessary. Do you think that that addresses your first concern?
Let me think. So I do understand that the model is more flexible, and I acknowledge that. But that's where I think specific requirements come in to figure out whether the flexibility and additional complexity justifies the additional complexity. So yes, hypothetically, this is definitely more flexible, but yeah, I'd like to make that concrete.
But what exactly would you say that the additional complexity consists in? Because strictly speaking, kube control, there is not that much that has changed in order to implement the external signer.
Not that much. I'm not sure if I would buy that. So the additional complexity is adding the external signer and maintaining it over time. That's what I was referring to.
It's also helpful to remember that it doesn't just touch kube control, it touches client Go, which affects potentially all client Go consumers. And there are other consumers that make use of aspects of the dialing and TLS verification and certificate, the certificate callbacks and things like that. And so if we're talking about adding authentication plugins to client Go, we have to consider what does that do to the surface area that lots of clients, including the kubelet and API server and scheduler and control manager, any client Go consumer is going to be exposed to this complexity.
So the way we currently implement is that the external signer is a separate authentication plugin, and basically all it needs is there was already existing infrastructure in client Go to hook the get cert method, and basically we're just hooking into that one, and instead of returning a real Go signer, we're basically just returning proxy to a signer that is then being proxied via the Unix socket. So from our point of view, as long as you're not using the external signer authentication plugin, basically the data path is exactly the same. And then let's say the magic only happens when you're explicitly using that kind of the external signer authentication plugin. Not sure if that addresses your concerns.
So I think sell me on this over implementing a exec plugin out of tree that uses the FIDO standard.
So I'm not really sure that they have the same yeah, they cover the same area, because my understanding is that in case of hardware security module, the hardware security module is, for example, free to decide to log each of the signature requests. It's free to count the number of signature requests. It's free to, for example, display a LED when a signature request is being done. So in certain environments, it can help a lot more on identifying potential intrusions and things that go wrong. Whereas my understanding of how FIDO or other similar approaches work is that the tokens that they issue would be a lot longer lived. I'm trying to find out the code in client Go that actually changes. Yeah, so just for reference, so the changes that we did to client Go per se are really just captured in this screen. So we're creating an auth provider TLS interface that is extending auth provider with also the possibility of updating the transferred config. And then if we notice that the auth provider actually implements this interface, then we allow it to update the transport config. So to most of the users of client Go, this should be a pretty transparent change, I would say. Hello?
Yeah, I'm just mulling it over. There is a non-zero cost, and for me, the requirements aren't very precise yet, at least in my head. Maybe I missed those in the KEP, but I would really like specific threat model or compliance standards that make a FIDO-based approach not feasible. Because I think in the long run, a FIDO-based approach is going to be easier to maintain for inside Kubernetes core.
Okay, we'll come up with some scenarios and with concrete standards for that.
Yeah, and I think there were other questions about whether we wanted a generic TLS offload for clients, or whether this was a specific integration for kube control.
So this is a specific integration for kube control, but that being said, there is a similar effort, kube KMS, which also wants to delegate encryption and decryption to some outside party, and this could be, of course, a hardware security module. I think that as adoption will grow larger, we will better understand. I mean, there's no reason why this interface couldn't be used by other parts of kubelet or kube control, as long as they need to retrieve a signature or, sorry, to get a certificate and to use that certificate for signature.
So I think the best path forward right now is to have people review the KEP and get the eyes on it that you need. I think we'd like to hear from both David and Jordan on the KEP.
I will have a read, although I'll be honest, some of the abbreviations y'all have been using are not ones I am immediately familiar with.
No worries.
So if you
I
can,
am calling you out for an authentication subproject.
Okay.
I can queue this up. I had not looked at it in detail yet, since it wasn't targeting 119. But if we want to set up a time, it might be helpful to spend some time on this together. I agree with David. I'm not as familiar with some of the externalizable TLS stuff, so having probably Mike there to explain things to me would be helpful. We want to set that up maybe sometime next week.
Yeah.
Sometime between now and
given the enhancements has already freezed for this release, I don't think that there's pressing urgency.
Right. Mostly, I'm wanting to be able to give crisp feedback so that the contributors can use the time between now and like the 120 deadline to respond and update and make this a proposal that is better understood or more acceptable, or we can just reach a conclusion. So I think having some feedback for them early would be helpful.
Yeah, next week.
That sounds good.
Doable to me. Next week, get up and we'll work out the calendars, Mike.
Awesome.
This sounds good. Let's take the scheduling offline.
Okay, so then we'll update the cap with all the comments we have accumulated so far until, hopefully until the end of this week, or otherwise until the beginning of next week. So then you can schedule it, and we can discuss it together. Does that work?
Sounds good. And as questions are answered, please make sure that the answers are captured in the KEP itself and not just in the comment stream on the PR.
Okay, thank you for all the feedback we got so far.
Thank you. All right, where's my window? Next up, we have next steps for managed CA bundles. Jaja, are you on the call?
Yeah, so I could take some time to brief this. Hi, this is Jaji from Google. So we kind of announced this effort in last sig-auth meeting to bring up some managed root CA bundle for the cluster level stuff. I wrote a small doc to summarize the different opinions and options in the original issue. There was an original issue discussing about why do we need this and how we plan to do that. So in the doc, we do summarize some of the motivations and some options of doing that. So I've heard like many people saying that they want some kind of basic mechanism to have a cluster level trusted CA bundle. So they could have some easy way to provide the certificate in the library. In the considerations part, we have several options which we don't have very strong preference. So I'd like to bring up here to hear more feedbacks to break the tie and kind of choose one of the options to start with some basic implementation or start designing something. So in terms of how do we inject the CA bundle, which is the primary design choice, we could use a projected volume to inject the certificate into the pod, or we could use a cluster config map. There are pros and cons of each option, but I couldn't tell like which option is better or which one is worse. So I would like to see more comments here. There are some comments in the doc. People are looking at it, and some of them are like regarding to stability or scalability, those stuff. But let's see whether people here have more
So a question about this, right? I
Yeah.
saw that it was initially focused on CA bundles and injecting them. It was less obvious to me how you were going to handle some of the mechanics around and what you intended, right? Is this going to be a way for the hosts running kubelets to have their system trust bundles changed? Or is this going to be something sort of unconditionally changing one of the base layers in an image, right? Are we going to force add this to existing pods? Or whether this was something that was going to be related to being able to recognize, say, certain signers, or whether it was going to support multiple roots of trust, and whether it was intended solely for CAs, or whether you saw this as a way to have sort of a global config map. And I don't think, basically I started it and I had all those questions and I looked at it and I haven't come back.
Yeah. So we are thinking of like injecting some of the very common trusted CA bundle into the images. Like we are not going to write the default like root CA stuff, but we are going to provide them as some extra like bundle stuff so that libraries could use these injected CA bundles to achieve some like stuff. We could make it possible for like cluster administrators to configure some cluster level CA bundles very easily, like through some mechanism. So like by default, like the pods in this cluster would have these trusted CA bundles being distributed to the pods. So yeah, that's the initial thoughts.
So is the stuff that you listed at the top where you were talking about admission registration and API registration, that's not related to this proposal? It's different than this proposal?
So these stuff are motivations, like
I guess I'm not clear on if you're trying to change the set of trusted CAs inside of pods running. It's not obvious to me how that's related to things like admission and registration.
Oh yeah. Like there are links to those issues. Like people from developing those stuff, they express some interest. Like if there is a mechanism to provide a root bundle in the pod, it would be easy for those webhooks API extensions to have. Like currently they use some template, so they need to copy the certificate into each pod's config map. It's kind of like wasteful. Like if we do have this mechanism, they could make. Yeah.
Yeah, sorry. I do think that it's an issue, the one that you have linked there for the basically the API servers CAs that it uses to trust webhooks. I think that's a pretty different problem from injecting CAs into pods. And I think that's maybe what David was getting at.
Mm-hmm.
I think those are both issues that we want to discuss, and I think they should probably be addressed independently.
Okay.
Yeah, I don't have an objection in concept. I mean, you can see we have a design about building a way to have sort of the idea of a global config map that a cluster admin opts into. We were exploring the idea in OpenShift. It seems like a good idea. We were going to go down the CSI driver path for it. It's not like, hey, I want this design instead of what you have. But if you're looking for like what other thoughts in the area look like, this is what those thoughts. This is where we went and some of the reasons we did so. But we did try to separate out the concerns about trust for something like an admission webhook versus the how do I generally provide this piece of information to any pod in my cluster. And it wasn't specific to CA bundles. And it was also explicit in what it did, right? There was a concept of an explicit opt-in, or at least visibility, that something like the root trust in your pod is not what you chose in your image. Because I think people really should be able to tell that they've been fiddled with.
I see.
And multiple chains of trust are important, right? Not all trust is the same.
Yeah. Yeah. And at the bottom part of the doc, we are still not finalized how we deal with like cross-bound, cross OS, cross-platform stuff. Like how do we inject this CA bundle into images of different operating systems, different distributions? Like they search the default CA from different locations. We are still thinking of how we deal with it. Yeah, so it's kind of like yeah. So kind of like bring up this doc in the sig-auth to see like if people have more thoughts. Like if so, like just comment in the doc. Like we could see like people's thoughts and improve our designs and break some times to choose one of the options to start with implementation.
Okay, I will take the time to certainly write up
Yeah.
several of the questions. I guess several of the questions are somewhat fundamental.
Yeah.
So.
All right, thanks.
And just to address the kind of original agenda item of what the next steps are on this, yeah, I think we should kind of iterate on some comments on the doc to get some kind of basic understanding in common. And then the next step will certainly be writing up a formal KEP.
Yep.
But I think it's okay to kind of answer some of the open questions on the doc first.
Cool.
All right, next up, I had added a agenda item about removing the insecure port on the API server, which has been deprecated since I think Kubernetes 1.10, and just says that it will be removed in some future release. We attempted to remove it, I think in 1.14, and that got reverted because it broke, I believe it broke COPS due to an issue with a requirement for insecure health Z checks, insecure meaning over HTTP. So I'm actually not sure if this is something that is sig-auth or sig API machinery's responsibility, but I would like to get a kind of a concrete deadline for removing that and a path forward. And just to add a little motivation, we've had some security issues in the past that get escalated in severity because of the possibility of exposing the API server's insecure port. So I'd like to remove the possibility for that escalation, and also make it simpler to score vulnerabilities that come in.
Are you interested enough in doing it that we just say gone? It's been deprecated for quite some time. We could make the choice that, you know what, you knew it was coming. It happened in 1.15 before. It's been deprecated for many releases. It's just gone now. But I'm not sure what else you would have API machinery do that would be different, right? Like what additional choice do we have?
Yeah, I guess
the main question so right now, if you have a load balancer or monitoring tool that doesn't have the ability to take credentials, it basically expects a unsecured monitoring endpoint. The only way to enable that is to either run it over localhost against the unsecured port, or to enable anonymous requests. And so
that's not entirely true. We do this for GCP by creating an HTTP proxy that only handles one endpoint with a credential that only has access to a single ready endpoint, right? I think there's other options.
Yeah, I agree.
Okay, I'm not as familiar with using a proxy to add in authentication.
It's not. I guess it's not even a proxy. It's just a thing that reads. It has credentials to read nothing but health, and then it exposes itself as HTTP, and you just run both.
And it can even listen on the same localhost port and be kind of transparent to things that are using that.
So other options do exist, but they are work for other people. But I don't think there's anything magic that API machinery can do.
I think adding descriptions of those to this issue would, like, laying out the options, make it clear, like, here's what you can do today without doing any work yourself. If you don't want to do that, here are other options you could do with work to get the network properties you want. Yeah. And that might even be worth actually documenting. Like, you know, how do you monitor your server? Here are your options. Turn on anonymous requests, and you can hit the health Z endpoint, or set up something like this. In an example.
Yeah, I can take that action item. I guess the other possibility is several components, including kubelet and kube controller manager, explicitly have an option for a health Z port, which is just exposing a HTTP health Z endpoint. So we could consider adding that to the API server.
I'm not super excited about that. I mean, I'm not super excited about having it on the binaries we have it on either.
Why not?
It adds complexity in the code path to actually start it. It gives you an endpoint that is not secured and protected by credentials. And now that those binaries do have authentication and authorization built in that matches the in-cluster versions, I don't see a reason to have it. Basically, we have it because it existed long before. And if we had had security on those initially, we would never have had separate ports.
Okay. Micah, I see that you're +1 for a separate health Z port. Do you care to elaborate?
Yeah, this is something, I mean, so today, like, we rely, I mean, this is just because we did this initially and we haven't really cleaned it up, but initially, like, we rely on the system public viewer, or info viewer, for health checks. And so it becomes a problem when people try to remove that. So it's just a separate health Z port that wasn't exposed to necessarily the internet, but that we could use for health checking without having to worry about enforcing like authentication authorization around would be really nice. I actually just had this issue come up in a document I was looking at earlier today.
Ed, but you do see how you can build one, right?
Yeah.
Okay.
But like just having to like today we're fairly unopinionated about what is inside the cluster, like in terms of RBAC roles or whatever. Like we don't, for the most part, we don't prevent you from doing anything except for this one RBAC role of the system public info viewer, because we're relying on that for health checks. And so, having to maintain like an RBAC role for something to access or proxy health Z is just, I don't know, it's more work than just saying, okay, here's this additional port we'll listen on and the internet's gonna not access it. It's just for like load balancer health checks or whatever. That would be a lot simpler for us.
I'm going to pause you there because I realize we're over time. Sorry about that. I will file a issue to track the removal of the insecure port, and then we can kind of follow up on that with some of the options. As a straw man, I propose that we set a deadline of removing it in 1.20, which kind of gives us a release to figure out the other options, and also give people a heads up that this is coming.
I guess I'd say no later than 120.
Yeah. Okay. So yeah, I'll file that issue and we can follow up there. All right. Thanks, everyone. Sorry for running over.